Now that we have configured the in and outputs and talkback, it's time to do the module settings. We will start with the processing presets. Here we can configure presets that we can use to set a module in a pre-programmed setting or get this setting back after power down or startup. In this demo we already prepared some presets of which we easily can change the labels. Here we have a DJ preset which we can see if we click in the column state. We will look now at what this preset is. Here you see the settings of the DJ preset. In the first column, called Override Module, we determine what the preset should do in the module. In case a yes is programmed here, the module will be overridden with the settings that are in the underlying layer. So in this case the digital gain will be set to 0. The low cut will be activated on 65 Hz and the insert will be switched off. Phase is not active, mono is switched off, and the module stays stereo. The EQ will be activated, dynamics is on, but module level and on switch will be unaffected by letting these to its off state, no. The insert is also not activated because we have here no and no. However, the EQ is on, which means that these EQ settings will be activated in this module. In this case, maximum available level is plus or minus 18 dB. Level is set to 0 and the frequency is on 7 kHz, 2 kHz and 3 kHz. We only use 3 frequency bands of the 6 available bands. The lowest bands are set to off and will not be used now. In the column bandwidth the Q factor is set and the waveform of the bands in the column type. This can be high shelf, peak, also called bell, or low shelf. Here we choose which one we use. We can also limit the range to, for instance, 12 dB for this DJ. If this DJ wants a little bit more high frequencies, we can do that here as part of the preset for this DJ. In this case, 3 dB extra. So when he loads this preset, he gets a little bit more high in his voice. By clicking on Save, this preset is saved. If we zoom in the dynamic settings, we see all the underlying settings that can be changed. The following parameters can be adjusted in the dynamic settings. The downward expander threshold is adjustable, automatic gain control ratio, and the automatic gain control threshold. This downward expander threshold sets the point from where the signal will be attenuated. In this preset it is set to minus 45 dB. It means all signals below minus 45 dB will be attenuated. This is called downward expanding. It's not a noise gate, but it reduces the signal level by the ratio that is set in the automatic gain control ratio. So, if the signal is far below minus 45 dB, it will be even more attenuated by this ratio. The third parameter is the automatic gain control threshold. From this point, in this case minus 12 dB, the dynamic processor tries to amplify the signal upwards to a nominal module level. And, in case the signal comes higher than nominal module level, the processor tries to reduce the gain again to the normal module level. The amount of gain and attenuation is dependent upon the automatic gain control ratio setting. In this case 1 to 2.12. In this way we can dynamically process the input signal, making the very low level signals even lower, the low level signals above threshold louder, and reducing the too loud signals to normal operating levels. This built-in intelligent voice processor makes it possible to reduce room acoustics. Especially in between spoken words, you do not want to hear the background noise. This is what the downward expander does. If a person speaks very softly, the automatic gain control will level the signals to around 0 dB, the internal module level. This is also the case with too loud signals. Now the signal will be reduced to 0 dB, the internal module level. With these dynamic settings, it is simple to program a preset in which a microphone signal of a DJ or newsroom presenter will always have the right level when on air. And when nothing is said in between words, the background noise will not come up again. Room acoustics will have no influence on the sound. Let's have a look at another preset. For instance, a hybrid preset. In this preset, the low cut is on. It is programmed to yes, and the low cut frequency is set to 150 Hz. Dynamics is off, not highlighted and off. Override module is set to yes. It's switched the dynamics off and the equalizer on. This is the way to make your own preset. If we go back by clicking on Processing Presets in the top of the menu, we will be back in the former menu. On this page you see the label Create New Preset. Here we create a new preset. For instance, a preset with only dynamics that we label Test. Zoom in on the new preset Test, and we now only want the dynamics is activated. We set the following parameters: AGC to 1 to 6 and AGC ratio to -12. In this way only dynamics is activated. Digital gain, low cut, insert, phase, mono, EQ and module will not be changed in these presets. Dynamics only. The result is the dynamics will be activated with this preset. How will it look like? -30 dB threshold for the downward expander, automatic gain control is set to 1 to 6, and the automatic gain control threshold is set to -12. This is the way to make your own preset in this mixer. By clicking on Save, I store the preset. Special presets can be made like this. For instance, this preset module on is a preset that returns all settings to a default value, such as digital gain to 0, low cut off, insert, phase, mono, EQ and dynamics to off. But module on and motor fader to 0 dB. A reverse preset is also there. When going back to processing presets in the top of the page, we see there is also a reverse preset already programmed. The model goes to on, but the fader goes down. These two presets can be used for a virtual module in which the on switch lets the fader move, in theory, from on to off. Such a preset could be useful for a newsreader or a jingle machine. On this page we program the module presets.